Hey TypeScript engineers, I'm very excited for the third and final video in our deployment series. This is very exciting because we're going to talk about the last piece of the puzzle. We're going to talk about how to deploy Express.js REST APIs to Firebase using Symmetric. So what is Express? It's really, at a high level, just a best-in-class Node.js server framework. It takes a lot of the really difficult things about spinning up HTTP servers in JavaScript. It makes it really easy. The combo that you get when you combine Node.js and Express, it's really excellent. It's a technique that we highly recommend. First, because it pairs well with the TypeScript monorepo that you get from Symmetric. You have your JavaScript SDK and React SDK. Using Node.js and Express is a good combo. It's very fast, and it scales up to lots and lots of requests. And last but not least, there's a huge community around it. TypeScript engineers really love it, and so you've got all these really cool libraries to complement the framework. So when you have an API that you want to spin up, the first thing to do is to think about it in terms of a pipeline. So you want to work on it locally, and a lot of times you'll have a local HTTP server that you're running, say in your Docker container, and then you want to deploy it to staging and lastly production. And the best way to do that when you self-host is to leverage, in our opinion, Firebase Cloud Functions, because you can take advantage of the full power of the Firebase ecosystem. If you are already using Firebase hosting, everything is already configured. You've got your Firebase project. You've got Firebase Analytics set up. Everything is really set up to pair well. And Cloud Functions is globally scalable. So let's see what this looks like in practice with a really cool live demo. All right. So the first thing you want to do is you want to actually head over to symmetric3d.com and create your TypeScript monorepo. And if you've been following along with our video about how to deploy NPM, SDKs, and Next.js web apps, you probably already have your full stack monorepo. But if you don't, it's very, very fast and easy. You want to just create a free account, or if you already have one, log in. So I'm already logged in. This will take me to Symmetric's dashboard. And you want to head over to your actual platform. So I've already got a couple in this account, but if you don't, it's very easy to create one. Just type in the name of your platform, say Expressly, because it's an Express app, Express, demo, whatever it may be. You can add all types of actual customizations to your platform. I won't dive into all this too much. Today, we're going to focus on the actual REST API portion of your full stack project. So once you have your platform set up in Symmetric, download the source code and then you can follow along. All right, cool. So I want to go through a couple different topics for this live demo. The first is how REST APIs fit into your TypeScript monorepo. So REST APIs sound daunting, right? Web apps, everybody can work on a web app. But when you hear REST API, you might think it's some kind of a scary thing. But that's not true. Really, it's just another workspace package from the standpoint of TypeScript and NPM. And you can see that when you head over to your TypeScript configuration file at the root. Notice how one of these points to the Express.js REST API, which is just another workspace package. The same goes for the workspaces field in your package.json file. One of these points to Express.js REST APIs, this entire workspace. If you want to, you can have lots and lots of REST APIs. That comes up sometimes when you have different types of users that are taking advantage of your solution. For this demo, we'll just focus on one. We have the Symmetric primary REST API that we'll do a walkthrough of. Okay, cool. So I also want to talk about how the REST API in your monorepo will have dependencies to the other workspace packages. So because this is designed to run in a server environment, not a browser, And for that reason, you won't be having any dependencies that you would see in your Next.js web app, such as React or Tailwind. But you will, however, have shared universal JavaScript libraries. So think Ramda, Luxon, or Xstate. And what's important for our purposes, you also have your actual JavaScript SDK that you define in your monorepo. And this is one of the really special things about Symmetric. We make it really easy for you to define these JavaScript SDKs that you can leverage in both your Next.js web apps, and as we'll see in this video, you can also leverage them in your REST API. So this is very important to note. You want to make sure that your JavaScript SDK is included in this dependencies list, and when you use Symmetric, all that's automated. So also note, you see a couple server libraries like Cores, Express, the backend Stripe library. These are things that you will not see in a front end, such as a Next.js web app or a React Native mobile app. Same goes for Firebase admin and Firebase functions. Cool. So hopefully that makes it a bit more clear how the REST API is a bit different from the Next.js web apps and how they fit into the monorepo architecture. There are a couple more very important things. The Express.js REST API is going to be deployed to Cloud Functions and not Firebase hosting. The other important two differences are that TypeScript is going to actually emit your JavaScript when you are building a REST API in Express. So if you take a look at your Next.js web apps, like we looked at in the previous video, you see that the build is a bit different. And that's because when you take a look at the build command, we're running next build. And the Next.js CLI is going to actually create your static site. But that's different from how the build process works in Express. We're going to use the basic TypeScript compiler. So for our build, we're actually just going to use the build command from the root, because when we run build at the root package.json, we'll just run tsc-s build, and we'll point it to the root TypeScript configuration file, which has a reference to the REST API. So we'll get our JavaScript emitted by virtue of having that reference defined. And then the last thing to make sure to keep in mind is that your environment variables for your REST API must remain private. That's because this is a server environment and not a browser environment. So for example, in your web apps, you may use environment variables for things like your open graph tags, like the name of your site or a path to a logo. But environment variables for your REST API are going to contain sensitive information like your API keys for third-party libraries. So just make sure to keep those private and don't check them into source control. That's enough for the differences, but there are also some similarities you see. So for example, you're going to have a Firebase configuration for your REST API the same way you have Firebase configurations for your web apps. So we'll see that in action in a bit, but notice how you can just follow along in the Firebase documentation to make sure that you get these Cloud Function configuration files correct. Okay, cool. So this isn't going to be a deep dive into how Express works. The Express team has phenomenal documentation, and I also recommend the Mozilla website if you want to learn more about how to use Express. But we'll dive into a couple different things just to make sure that you can go through the pipeline that we discussed earlier. And that's building locally, having some test runs in a CI environment, and then lastly deploying to production. So the express.listen command, that's the function that will actually spin up your Express app and let you make requests to it. So notice when you create a monorepo with Symmetric, we'll drop that into a file at the serve, called serve.ts. And this is going to import your Express app that you define and add all of your routes, add all of your functions, cores, all that good stuff. But when you want to actually run this locally, you use the express.listen command. And you want to pass in a port number. We also log the version. So without further ado, let's kind of take a look at what this kind of looks and feels like when you're running your Express app locally, with the idea that once we get everything working the way that we want in our local environment, we're going to actually bundle it up and deploy it to Cloud Functions. One of the other nice things about creating Express apps with Symmetric, we include some nice logs for you. So we'll go through all of this in detail, but notice I'm already running the command, the npm run dev command that will spin up this Express app. So the port number is, let's see, 6001. And so right now we have the Express app in this monorepo running. So let's actually see what a couple of these requests look like. And for this demo, let's go through 3 different types of health endpoints. The benefit of having health endpoints, well, there are lots of benefits, but one of the main benefits that you get when you have health endpoints, you can make sure that your Express server is healthy, so that will save you time when you're debugging. You can also make sure that your logs are behaving the way that you expect. Okay, so let's run 3 of these commands, and for this, we'll use localhost. So if we run this first, post request to health-ok, all we're going to get back is okay. Nothing too fancy there. But under the hood, what's happening, we have a couple things that are happening. But notice we have this Express app that we pass to this function called add health routes to Express app. Yeah, straightforward name. But we add a route and we define the actual function that we're going to pass to that route. And, you know, we have all these cool things that you can do with Express, which we don't have time to go over today. But notice how in the actual implementation of this, we're going to leverage Express's pattern of middleware. So we're going to do all of our operations. We're going to, in our case, we're going to set the response value in res.locals, and then we're going to return next. So this is what you commonly see as a middleware pattern. You can do some things at the start, then you actually process the request, and then you can do some things after the request is processed. Cool. So this is the simplest of the health endpoints. All it does is return success true. So if you call this request and you see success true, you know a couple things. First, you know that the Express app is live. You know that the endpoint that you set up is configured properly. So sometimes you might make a mistake and have the wrong HTTP method. So when you have health endpoints, you can catch those types of things. Cool. So the next health endpoint is a very important one, because what this endpoint shows is that your monorepo is behaving properly. It sounds a bit boring, but I mean, it is very important. So I'm going to quickly talk about what we see here. So I just made a post request to an endpoint called v0 health/js SDK. And what this endpoint does is it runs a function that we define in our JavaScript SDK from the Node.js environment, and it returns the result. And so if you see this command working properly, what you can have confidence in is the fact that your Express.js environment is going to be having the same access to shared functionality that you get in your Next.js web apps. So what this does is it simply just calls, it's pretty straightforward, but it calls the it reads the API object collection ID, and it just passes whatever API object that it receives. Inside of our Express app, what we did to actually create this functionality, we imported the engineer's API, which has a lot of logic baked into it. It has things like the yup type. I'm going to go to this implementation. So it has the yup type of a Symmetric engineer. So when you create an engineering account in Symmetric, we're going to store basic things like your username, your name, whether you were invited into a team or started fresh, etc. Lots of things to make the actual platform work. But as a full stack engineer, you know, a lot of times you have to actually leverage this in both your front end and your back end. And Symmetric makes this really straightforward to do. And that's what this health endpoint is verifying, that we can use all of the type definitions that we create and the actual source code that we write. So this engineer's API has lots and lots of really useful properties on it. And the one that we're seeing right now in action is the collection ID as well as the actual definition of the object. So notice how this file is inside of the REST API, but if we leave out some important fields, let's say we leave out the username, we'll get a nice TypeScript error because we've defined this type in the JavaScript SDK, and now we're actually creating the object from the Express REST API. Cool. So I highly recommend playing around with that. Try to break this and then fix it. You'll get a better handle on how the monorepo works as a whole once that clicks. Very nice. All right, so cool. So the last health endpoint that I want to deep dive on is the Firebase health endpoint, because this is how you can actually start to build real world applications and not just some local host that's making random mock data. So let's run this third request and see what we get back. So that's pretty fast. That's a good thing. Well, what we have here for this third health endpoint, we have our Firebase kind of proof of concept. All it's doing is reading a test document that we define at this path _test/0. It's going to read that from the database. It's going to simply package it up and return it to the caller. So as you can see, this is what the response looks like. We get the test doc data, and if we head over to the actual Firestore collection, array field here called hello world and the quick brown fox, yada yada, all that jazz. I won't dive into that too much, but we have some very interesting things here, because this is a way for you to validate that your Firebase admin SDK is working properly and that you can access Firebase services. Cool. So that's the third health endpoint that I wanted to quickly show. And notice how all this is running locally. So that's the first step in your pipeline. You want to make sure that you can actually have a representation of what's going to happen in production, and you can make changes to it. You can do this from a feature branch, and you can do it from a test Firebase project. That's the recommended practice. Cool. So lastly, I want to quickly demo that the requests that we just made to our local host, they behave very similar, in a very similar way to the requests that we make to the actual deployed instance of this REST API. So instead of localhost 6001, this is the cloud function endpoint that you get when you create a cloud function and deploy it. And so if you take a look at the actual logs, we'll refresh this, we'll see, yep, so we just got this status code 200, everything worked well. What we see is this is the actual log under the hood, what it looks like. It looks very similar to our local version of the request. So we're seeing all these logs. We see, some post requests. We've got headers, base URLs, all that. But notice how the host name, when you run locally, is localhost. The host name is your actual Firebase Cloud Function host name, but the actual functionality is more or less the same. So when you want to make sure that you've configured everything properly, the best thing to do is if you use Symmetric, you can just be very confident. But the best thing to do is to make sure things work locally, deploy them, and then rerun everything that you ran locally to ensure that you have a consistent configuration. Cool. So with that, I'll pause on the discussion of the health endpoints. For this video on REST API deployment, I want to quickly wrap up by talking about what it looks like to cut new releases of this REST API and actually deploy them. So once again, the assumption is that you've already created your monorepo in Symmetric and you're working with the actual code base. So at a high level, the most important file that is going to drive your deployment process is this workflow that you get for your REST API. And this has a lot of logic that is based on the expected type of package that Cloud Functions needs in order to run your application. Ultimately, when you have a Node.js Cloud Function, the function itself is just going to run in a Node container that is hosted on Google Cloud. So what you want to do in order to deploy new versions of it, you want to build your project the way that you are doing locally with the TypeScript compiler and watch mode. And after you've built it, you want to run the Firebase deploy command using the Firebase CLI. So let me quickly show in the package.json file what that looks like. So as you can see, we have a npm script in here for deployment, which runs Firebase deploy. It's helpful to turn on the debug flag. Once you get things working, you don't really need it. And then passing in the only functions flag will also make sure that Firebase deploy doesn't expect websites or anything else. The third flag that this npm script includes is the Firebase token, which you can get by simply running Firebase login CI and then add the Firebase token as a repository secret. So if you head over here, you can see that there's one of the repository secrets that you want to add to your GitHub repo is Firebase token. And then when you do that, the Firebase CLI will be able to authenticate your deployment script and then actually deploy your Node.js Express app to Cloud Functions. And that's what this workflow assumes that you have set up. So I'm going to show, when you create a monorepo in Symmetric, you get these example files, but ultimately you want to have your actual platform's data in the place of these examples. So you want to create a service account to use the Gmail API, and then you want to set all of your environment variables. And once you do that, the deployment script will take care of the rest. And you'll be able to deploy new versions of your Express.js app to Cloud Functions with all of your environment variables configured the way that you have them locally. And this is nice because when you use GitHub repository secrets, you can update these on the fly. For local development, we recommend that you use some sort of a secret manager, like a password manager, and don't host these sensitive files locally on your machine. That is not a good idea. Okay, cool. So with that, we've gotten a good sense of how the actual deployment works. And you can see that when you have your monorepo working locally and are finally ready to deploy. And so make sure that when you are ready to release new versions of your Cloud Function to turn on Firebase Blaze Plan, and then you'll be ready to go. All right, so I'll close out this demo by also talking about how the entry point file works. So once you have your Express app working the way that you want it to work, you have all of your routes, you've checked everything with health endpoints, you've got all your environment variables. The most important thing to close out with to make sure that you will actually be able to use this in production is to add the correct exports to your entry point file. And so by default, Symmetric will generate a monorepo for you that has the structure of a lib directory, and then the actual JavaScript is emitted to a dist directory. Inside of this lib directory, Firebase is going to expect a file called index.ts, or really, ultimately, they're going to expect a file called index.js and dist, but you get the point. You're not writing these yourself. But inside this entry point file, you're going to export what you want to see actually exposed to Cloud Functions. So in this case, there's a Symmetric production API, and this is the actual value that you're going to have as the identifier for your API. You can also leverage all of the cool things that Cloud Functions gives you. For example, if you want to add Firestore triggers, this entry point file is where you do it, and the name that you use is what is going to appear in the Firebase console. So yeah, so I highly recommend creating a platform in Symmetric. You'll be able to play around with all this cool stuff, and most importantly, you'll be able to see how the full power of a TypeScript monorepo can come to life when you have all of your SDKs, your web apps, and your REST APIs fitting together nicely and working well. All right, so with that, we're going to wrap up for now. If you have any questions, as always, feel free to drop them in the comments or head over to our Discord server. Thanks, everybody, and we'll see you next time. Peace.